You've probably heard the term heat dome, but nobody has really explained what it is. It sounds dramatic, like a glass lid dropped over half the country. But here's the part that's rarely explained. The dome is not just hot air sitting at the ground. The dome is the actual shape of the atmosphere above you during a heat wave. A heat wave is the impact of a heat dome. Several days of abnormally hot weather, sometimes with brutal humidity and nights that never cool down. A large, stubborn ridge of high pressure aloft that traps, compresses, and recycles the heat. Let's build it up from the ground up. In this diagram, imagine two columns of air side by side. A cooler column and a hotter column. Warm air is less dense, and just like anything that warms up, it expands and takes up more space. So the hot column expands upward because air can't go down into the ground. Meteorologists don't only look at height in feet. We look at pressure levels, with pressure measured in millibars, 850 millibars, 700 millibars, 500 millibars, 300 millibars, because pressure decreases as you go up. Roughly speaking, 850 millibars is around 5,000 feet, 700 millibars around 10,000 feet, 500 millibars around 18,000 feet, and 300 millibars around 30,000 feet. But these levels are not flat. In warm air, those pressure surfaces are higher because the hotter column of air takes up more space. In cold air, they're lower, relatively speaking. So when a warm column sits next to a cold column, the upper atmosphere actually tilts down toward the cooler side. That tilt matters because air responds to pressure differences. The pressure gradient force tries to push air from higher pressure toward lower pressure, but on a rotating Earth, the Coriolis effect turns moving air to the right in the northern hemisphere, as you saw in this video. When those two forces balance, the wind flows roughly parallel to the lines of constant height along a pressure level. That's the geostrophic wind. For more on the geostrophic wind, check out this video right here. Now, here's the key. Because warm air expands the column, the height difference between warm and cold air gets larger as you go upward. The slope gets steeper. A steeper slope means a stronger pressure gradient force and a stronger geostrophic wind. In plain English, the bigger the temperature contrast between air masses, the stronger the winds become the higher you go. Stack that over thousands of miles and you get the jet stream, a fast river of air near the cruising altitude of jet aircraft born from the battle between warm tropical air and cool polar air. Now look at a weather map. When the jet stream bends south, that's a trough. Cooler, stormier, unsettled air. When it bulges north, that's a ridge. Warmer air, higher pressure aloft, and often quieter weather. But on a flat map, a ridge just looks like a bend in the jet stream. But in 3 dimensions, that ridge is actually a dome. Weather is not just what happens at the surface where we humans live. It is the whole atmosphere stacked above us, moving like an ocean we live underneath. If you want the science behind the forecast without the hype, subscribe to Untamed Skies, where we follow the weather from the map to the sky to the people living under it. Check out the link below for the full video about heat domes. Keep looking up.